Hi everyone, we are Group NumPy, and our project is Distance Metrics and Similarity Design for Recommendation Systems. Our team of 5 built a crop recommendation system. Let me walk you through it. Our talk has 5 parts: introduction, related work, our proposed method, experimental results, and finally the conclusion. So why does this matter? Crop choice directly affects farm productivity, yet soil and weather conditions vary by region, and crucially, several crops can suit one field. But a seeding system returns only one predicted crop, giving farmers little decision support. That gap motivated us. Most prior work treats this as classification, evaluate top one accuracy, and ignores ranking and efficiency. We ask a better question, not what is the rub, but what are the top rubs in order. About the scope, we study top K recommendation using distance-based retrieval. Objectives is to build an exact KNN baseline, propose a K-means and accelerated KNN, compare both on ranking, quality, and retrieval efficiency. We survey for families, rule-based, classical machine learning, deep learning, and foundation models. The common thread: almost everyone does classification, and no one analyzes ranking or retrieval efficiency. That's the gap we target. Talking about our highlight, median imputation and standardization, essential for distant methods. Then a stratified 70-10-20 split. This fits two models, an exact class Y KNN and a K-means accelerated KNN. Both score with MAP of K, NDCG of K, HitRate of K, latency, and candidate ratio. Our inputs is this one: 7 soil and weather features. The output is the top K most suitable crops ranked by similarity with K5. Here's our contribution. Instead of comparing a query to all training samples, we cluster the data with K-means and shut only inside the nearest cluster, controlled by a parameter called nprop. The payoff: far fewer candidates and better scalability, with 2 tunable knobs, ncluster and nprop. We use the public crop recommendation dataset with more than 2,000 samples, 22 crops exactly, 100 each, split stratified, 1,540 trend, 220 validation, 440 tests, with a fixed set of 42 for reproducibility, and the split happens before any preprocessing to prevent leakage. We rank with this one, plus latency and candidate ratio as well, and MAP of 5 is our main selection metric. We test 3 distant metrics: Euclidean, Manhattan, and cosine, sweeping 12 baseline and 108 hybrid configs. The best setup is then we train on trend and validation and evaluate it once on the held out test set. And yeah, the results are excellent across on metrics. MAP of 5 reaches 0.974 to 0.992, and HitRate of 5 is a perfect one. The correct crop always appear in the top 5. The best config is K-mean with Manhattan distance at MAP of 5 is equal to 0.992. And critically, K-mean costs 79 to 87% of candidates per query. Without hurting ranking quality, the strategy works now. But here's an honest twist. Despite fewer candidates, the hybrid is slower in work log time on this dataset, 0.82 to 1.47 millias versus the baseline 0.06 to 0.12. Why? With only 1,760 samples, the baseline vectorized NumPy search is so fast that the hybrid Python level clustering overhead outweighs the saving. We report this openly. The candidate's reduction benefit is real and would dominate at larger scale, also consistent everywhere. Manhattan-based Euclidean-based cosine. So in summary, we reframe crop recommendation as top K retrieval, achieve excellent ranking quality, and show K means shrink the search space by up to 87%. Though on this small dataset, it says KNN stay faster, the finding is honest and well supported. Next on larger diverse dataset where the speed benefits should appear. Try FAISS or HMSW, something like that, indexing to remove the Python overhead and explore learn distant metrics. So these references on crop recommendation, KNN, tabular foundation models, that type of thing are detailed in our written report. So that's our project's top K ranking, strong quality, and an honest efficiency trade-off. Thank you very much. And now I will hand over to Tan for a live demo. Over to you, Tan.
Hello everyone, I'm Tan and I will continue to present our demo for the project recommendation system. So in this project, we're using the Streamlit to build the UI system. So at first, the user can choose the model, which is the hybrid or the baseline KNN. And then the user can choose the top K recommendation. For example, in here, I will choose the K is equal to 4. And then the user also input some feature like nitrogen, humidity, temperature, pH, and so on. And then the right hand side will display the table of the summary input. Now we will generate the recommendation. So here we can see the first one will be the best match with the input feature of the user, which is the kidney beans, and the second one is pecan peas, and so on. We also print out some information about the model like candidate scan, candidate ratio, and the cluster. This one we will use for the hybrid model. And we also have some information about the model comparison for the KNN baseline and the hybrid KNN. In here, we can see the KNN baseline validation. We validate on 3 distant metrics, which is the cosine, the Euclidean, and the Manhattan. So after validate, we can say that the best model is of the baseline is the Manhattan with the neighbor crop is the 10. And for the hybrid model one, we also validate on the same 3 distant metric, but this time we will use also the cluster for this hybrid model, and we observe the best model is the model with the metric distance is the Manhattan with the cluster and A16. And we also print out some information about the test of the 2 models. And here's our snapshot. That's the one I want to present you guys about the dataset we used in this project. Here's our information about the dataset, which contains 22,000 rows with 7 features and 22 classes. And here's some sample rows of our dataset. And as we can see that the class distribution of each label is balanced, with each label will contain 100 samples. And here's for the feature summary, which contain some information about the mean, the mean and the max of each feature. And that's all for our demo. Thank you for listening.